Hello and welcome. I'm Bill Wake. We're here today working on the Elm interpreter. We've been at it for a while. We're working on expressions and trying to get recursive functions working. But what we ran into that's in our way is that our operators, they they short circuited the types. Basically, they just said unknown, and we're paying the price now. So we're going to address that. All right. So I heard test just finished. Yep. All right. So everything's good there. I'll tell you, I tried replacing, well, I did replace Xcode with a fresh download, and I've still got that bug when I create new files. So who knows? um, let's see. So, yeah, so we left off with, we have these functions. So here's a numeric type. The plus function is basically the integer plus or the real plus. So this convert function types, it converts. It decides when you give it an argument which of these should apply, and produces a function of two. Well, it's a function of two arguments producing another one, and we curry it, which means we turn it into a function of one argument, returning another function of one argument. Now, I fading out. I think this is saying the from, type 1, type 2 goes to type 2, because our type for plus is number goes to number. And I guess we want to see if this is working. Right, left-hand side, right-hand side goes to result type. And till now, we've had everything be unknown. So I guess what we want to do, let's just run this thing. And we should see a difference between plus and times, because plus knows about number goes to number. If we're using that, I guess I don't know that yet. We may have just started down on the path and not got very far. So if we say 3 plus 4, that should be two numbers there. Okay. If we do 3.0 plus 4.0, I'm not sure. We probably get numbers still. No, we get float. Okay. Well, that's a good thing. That's the rules for number versus float. If they're both numbers, it's number. If either one is float, it's a float. Okay, now let's look at plus 3, 4. How about just plus 3? This thing should be a function from a number to a number. No, it's not. It's a function. It should be a function from a number to a function from number to number. Don't you love this stuff? Okay, so let's go to to do and talk it through a little bit. Okay, so we expect the type of plus to be number. Well, it's really this is kind of the way they write it. The first number goes to the first number produces a function that is a number to number. So you can parenthesize it like this. Arrows right associative is basically what it's telling you. Okay, so plus number goes to number goes to number. Let's see what our thing does when we ask it about plus. I think it's just going to say number goes to number. No, it's number goes to number goes to number. Oh, maybe we're okay. Plus of 3 is a function from number to number. That's right, because if you give us a 4, we'll return a number type. Okay, we're good there. Now let's look at times. Unknown, unknown, unknown. Okay. I think we just have to go down the path of these things. I'm not sure if we have a test driving this. And they pretty much are whatever you tell us they are is what they are. And that much is true. So we should be able to just do the arithmetic ones copying this. Okay, so minus is going to take 3 more arguments. And curry is going to take another set of 3. And this is another numeric function. Well, that's the numeric function numeric types. Let's just do those. Int power pow and these things. Okay, so I don't know if any tests will break over this. There may be some that we're expecting unknowns still, but I think we're okay. All right, good. And now let's just run the REPL. What is the type of star? It should be number goes to number goes to number. Yep. And let's look at this one's a little different. Slash and slash slash. Slash. Float, float, float. And then slash slash, I think it's going to be int, int, int for the first time we ever saw that. Yeah. Okay, so slash float, float, float. We'll take these 3 again. Slash ElmType.float. Float. Float. Okay. And I don't know, do we have int here? Oh, we don't. Okay. Number, okay, power is okay. Percent is okay because we don't do anything with it. How about these equality types? They're interesting too. Okay. So this is the int, float, and Boolean version of this thing. Let's go to the method. Expression function. Expression goes to Boolean. They all result in Booleans. And so the type of equals equals, I think is like A goes to bool. Don't know. Yeah. Okay. And we call that a generic, which it's okay. I think there's more to it than we're doing, as often is the case. But basically, you can end up with like a goes to bool says that the 2 A's have to be a compatible type. And that's reasonable, right? I mean, if they're not compatible, they're not comparable. So I think that one's we can call it generic, but there are circumstances where you can get A goes to B goes to C. Let's see if I can define a function like that. I want to do a function of A and B. I'm going to return A comma B. And I think it's going to be A goes to B goes to A comma B. Yeah. So you can get 2 generic types as long as you don't try and combine them with, an arithmetic operator or something like that. What if we do function of A, B equals A or B equals B? A1 goes to A. Okay, so I don't know how it knows when to say A to B and when it says A1. That's a kind of an odd difference to me. I don't know if it's meaningful or not. I mean, it sort of seems equivalent to A goes to B goes to bool. You give 2 different types and you're fine. A1 and A sort of implies they're compatible in some sense, and I don't know. I mean, they both have to be what's it? Comparable? Is that what they call it? There's a word for it that they have. For comparisons, you have to be a certain kind of compatible, and for arithmetic, numerically compatible and stuff like that. So let's take, A goes to bool. So we'll do generic goes to bool, and I'll just borrow this again. Save me typing Elm type over and over. Generic goes to generic goes to, let's see, do I have bool somewhere? Yeah, bool type. Up here, right? Yeah, it's an Elm type. Okay. And this one's the same as that one. I don't expect any test failures. The funny thing is, no, we're requiring, generic to generic. Yeah, there's a little gap here between us and Elm. Just a slight one, right? We return basically A goes to bool. That's fine. But if you define a function, I don't think we're doing definitions quite right anyway. But if you define the function, we definitely don't. We definitely wouldn't produce that one. I don't know. We might be able to do this and see. But I almost think it could even blow up. I don't think we have enough stuff on the definition side to allow it. But we'll see. Function AB goes to pair AB. We only have one generic, so we don't distinguish that. So this sounds stricter than it has to be. I don't know. Can we try it? Function of 3, 4. Is the pair 3, 4? Generic? Yeah, we don't know how to get them back down. It really should be int, int, I think. Let's see. So function AB equals A, B. Function 3, 4. Function 3, 4.0. Okay. Yeah. I guess each one could be int or float and separately convert. Right. And we're stricter. We say, it's just generic as generic. And then we lose track that it's actually a stricter type here. So up here it thinks the type is A goes to B, and here we think the type it thinks the type then should be specifically number or number float, and our side we just think, we said it was generic, it's generic. So we don't go back down and try and get the most specific type. So that's a flaw as well. But okay, we made progress here. The only one, let's see, this one doesn't. Okay, so // let's see what the deal is here. We did it up there, int. Oh, we don't have an int type yet. Interesting. Okay, but I think we've converted. This one's funny. %. I don't know what they tell you here. It's an error. Okay. And I think I don't know what we do. Maybe error expression. Unknowns. Well, it probably should just be error. Unknown goes to error or something like that. Let's do that. ElmType.generic. 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 error. Okay. And I'm just going to open these up a little bit. I don't think I have super consistent spacing rules, but when it gets unreadable, I definitely try and add more space. Like, hey, why don't you fix the unreadability? Oh, that's another way. But I don't, every bit of stuff here is kind of adding something. And partly that's because we're shifting domains, like these things, these arguments where we pass in just the operator, that's really converts it to a Swift function, or it is a Swift function. Type, comma, type goes to type, almost like a tuple, maybe not exactly, but kind of in that ballpark, a 2-argument function returning one result. Curry takes that and changes it. Now we could push the curry off to the people who call this. There is that much duplication here. And maybe you could fold these three together somehow. All right, let's make sure that's going. And so we've got everything except // Now I'm gonna run over here while we're doing that. So when you say 3 is a number, 4 is a number, when you say 3//4, it looks at it and says, is this number compatible with int? And if so, I'm going to convert it to int. So we have to worry about the kind of runtime actual type. And in that sense, it's even our interpreter is mostly strongly typed at the value level, kind of like JavaScript, right? Typed at the value level, but maybe we're not as tightly typed up at the top. But at any rate, we know, even though we call this a number, we know it's really an int. And the 3//4 forces it to int, so it converts both of them down where they belong to int. I mean, down to their fundamental nature, and then the result is always int. Okay, and it's an integer divide, so 3/4 is 0 and 4/3 is 1. All right. Now numbers. Okay, let's push this. So make operators know their. I think it's really both their Swift and Elm types. Okay, so our operator functions are more accurate about what's going on. Now I don't want to be too harebrained or anything, but I think this, we shouldn't leave this. Like, we got everything else right, and we could almost take out curry and only allow it with actual types, which seems like a good move. I mean, that's kind of what it should be for our purposes. We need to know, like, so you have this Swift function for me, and what types is it going to produce? I can't tell from looking at it. And you can see they vary, and curry doesn't care. It's a very flexible function that way, but it needs to be told what the real types are. And you could probably, well, yeah, convert numeric types is a function. Let's go to it. Jump to it. So it's just a static function that turns Swift functions into expression functions up at the interpreter level. Okay, so it's a handy conversion, but it doesn't have knowledge of what its types are per se. It just knows, if I have both integer values, return an integer value. If I have an integer and a float, or two floats, return a float value. And so that's where you can see the actual type is really being maintained. And And we know 3 plus 4 return number, not integer, so that's okay. All right. Yeah, so we committed that. Let's just go up a level. Make operators tell their actual type. We're almost done with that, but make integer / know the int type. Okay. And for that, we're going to go to ElmType. Okay. And this is really the possible types in our interpreter right now. So error is actually a known error. Unknown is what we had. Like if we don't know, we punted and said it's unknown. So we should see who uses that. See who uses unknown. Okay, it was our operators were doing it. Oops. The operators were doing it, but maybe we got rid of all those. I don't know. I kind of doubt it, but maybe. Generic is the A goes to whatever. Number is int or float. Float is float. Custom type is like Boolean. Function types, and then tuples. Okay, so we're kind of getting most of them. I mean, you can have arrays and records. I think that's the two big types we don't have, and those are both compound in the sense that they're built out of smaller types. So you can be an array of integers or an array of floats or whatever. And same thing on the records. You're they call it a union type because it's a bunch of, you can be different types. So you union, like any kind of record it's basically a record. So you could have an int and a float and another float, and then you're just kind of the cross product of those. The union is like multiply, so int times float kind of covers the domain of those things. Let's see. So that's product types. Some types, just to fill it out, are the custom types are more like that. So Boolean is false or true. If you want to consider how many cases you do, you have to add them up, All right. So if you have a Boolean cross a Boolean, there's 2 times 2 possibilities, but each of those, the 2 was 1 plus 1 for false and true. All right. So we don't have an integer type. I don't know if we need a lot of, what do we want to do? Let's find what we do for testing right now. Well, tuple equality. I mean, we could make use of it. That'd be something. So like here, well, okay, we could do, if we did 3//1 and 4.0, I expect this to be type tuple of int and float. Okay. So tuple is another product type. But it picked up that 3//1 is an actual int, not a generic number. I don't know if you're int or float. If you did an integer divide, you're definitely get an int result. Okay, so if I have a tuple of type integer and float, I think the capital I int, then I expect to get int back. All right, this will break. And before I wasn't worried. It's just, well, maybe I should make a new test. Let's do that. Tuple type format with integer and int, and that should fail. Well, not just because of syntax. Okay, integer doesn't exist. We'll go in and create it. And then it's going to complain about a bunch of stuff. Case integer. And then that creates problems in here because it's an enum, so you have to cover the cases. All right, we don't have integer. Okay, so case.integer. Let's return junk for now. Okay, description and hashable. I don't think I care. We'll let that one go. It's just mixing in something. And then there's one more. Nope. Okay, let's see if that did. Should still fail. I just returned junk for the type name. Description. Probably could have run one test. Oh, it didn't find it until I ran it. Okay, but that's the only fail. And int question marks, right? So let's repair that. I see joint type. We'll need to address that too. But this one is int. Okay, and I think we can reorder this a slight bit. Integer, float, and number. That's kind of okay. That test should pass. Now this joint type thing, oh boy. If your float and number, return float. If your number and float, return float. I guess the deal is if your float and integer, you should return float, right? We're going to convert our integer up to float. If your integer and number, I don't know what you do. Let's see. So if we, it's probably number. Let's do 3//1 plus 2. Okay, so that's int. So it's a little tricky to get the semantics here, right? We're trying to say, well, what we've got is plus is number to number, and / is int to int to int. If we did 3 plus 2, we get number. But if we do 3//1 plus 2, we get int. So I guess what that tells us is if you try and combine an int with a number, then we know it should really be an int. So a number is sort of like an int that could be converted to a floating point, I guess. All right, and then let's do this one. 3//1 plus 3.0, we expect to go to, both int or both plus. Right, okay. So this is showing you why number goes to number matters. You could, if you had number goes to number 1 goes to number, I think we did up here. Number goes to number. Well, we got a number 1 here. But if you had number goes to number 1, then they could be independent. But they're required to be the exact type. So int and number is okay. Float and number is okay. But float and int is an error. All right, well that's good to know. Let's encode that in a test. So what did I just say? Float and number goes to float. Int and number goes to int, and float and int goes to error. All right, I think that's what we saw. So 3.0 plus, let's see, 3, that's an int, plus a float is an int, as an error. So yeah, it's symmetric. Float, int and number goes to int, number and int goes to int, and int and float goes to error. All right, and this is joint type, so let's go find where that's tested. Joint type, error joined with anything. Type with same type yields that type. Float with number yields float. Okay, that's something we already said. Float and number goes to float. Float number. Let's do the flip as well. Number with float goes to float. All right, so that test I expect to pass. Okay. Now we're going to make a similar test for int and number. Test int joined with number yields int. Okay, so int integer with number yields integer. And number with integer yields integer. All right, this test I'm pretty sure is going to fail because we don't look at anything about int. Good. 4 failures. Int goes to int, and what's up here? Oh, okay. Left and right. Oh, that's our check for it. Okay, it already checks both directions. Okay. Let's take the redundant one out then. Okay. Now, because it's a symmetric kind of function. All right, so now we want to make sure number plus int yields int. And I think we're just going to have to do this same sort of thing here. It doesn't matter because they're independent, so I can check them. Returns integer, number and integer, returns integer. Okay. If either's an error, it's an error. If they're the same, it's okay. If they're generic, yeah, we'll take the other type. Okay. And if float and number, okay. Otherwise, return error. Oh, our test, our next test, I think, will return an error. Error joined with anything, something with the same type. Okay, we can do this one. Int joined with float yields error. Integer with float yields error. And this is, I think, a confirming test because I do believe this should pass as is. I guess we didn't ever have the chance to test float versus int, though, because we didn't have int in there at all. All right. But it also tells us float versus bool, is not going to work. So let's go in the REPL. So if you did 3.0 plus false, right, not legit. False value is a Boolean, but plus only works with ints and floats. Okay. So we added new ElmType ElmType.integer. Its description and its joint type with anything else. Right. Okay, so now let's go to part 2. Make integer know the int type. Okay, we haven't done that. I guess what we did do, well, we added an integer type. So let's make, what's our story? Function calls, it's more like operators. 21-21-0420. Story infix operators, and created ElmType.integer with its description and joint type. And I'll capitalize this just to be extra clear. Yep. All right. And now make integer / know the int type. All right, let's see if we can do that. And I think we're doing it implicitly, and that's okay. ElmType.int, ElmType.int, and ElmType.int. Okay, so if you take the integer, I mean, it's only going to accept integers, and do the divide. All right, let's take a look. Integer function knows it takes a function of integers where we passed the slash, which is integer divide, and then it makes sure both types are integer before it does the work. All right, so there's kind of this balance of when are we deciding, the proper types and all, how they merge together. This is sort of coming out of that joint type thing. I mean, it's compatible with it. We're saying they're both integers. It works. Otherwise, it's an error. Okay. Let's try. Well, let's make sure test pass, but then we'll run it. So before, when we ran 3//4 got unknowns. And now it should be ints. All right. Three, 4 is a number. That's not quite what we're after. 4, 3 is a number. Okay. Something's wrong and we don't know what. Okay, this is an int. Well, let's look at the operator itself. We want it to be int goes to int goes to int. What is it? It is. Okay, so somebody along the way. Well, 3 is a number. I mean, it's getting the right answer. It's the integer division. 3 divided by 4 is 3/4 or 0, rounded down. 4/3 is 1, rounded down. All right, so when you say 3, you definitely get a number. And when you say 4, you definitely get a number. So it's something about converting number to int. So yeah, we're down to the real... What does number mean? That's kind of a fundamental question here. Elm, what does number mean? I don't know if we'll get lucky and find the right answer, but what is type number? Yeah. Okay, not the only person confused here. It's syntactically similar to the name of a value. You can have numbers. Infelicity. Yes, I would agree. It's an infelicity. It's a built-in type class. Convention using number or comparable. Yeah, that's the A goes to A, or A equals A type. You could specify it consistently. Number A goes to A goes to A. Exact meaning can be explained later. Yeah, that's my experience. Always tomorrow, never today. Description that does what its name evokes. Reading types, primitives. We haven't dealt with type annotations. You can specify those yourself if you don't have to intuit them. And type variables. Okay, so yeah, list of anything goes to int. That's fine. Constrained. Mostly number. Negate uses it. Okay. Number permits ints and floats. But the confusing thing is if you have a float, I mean, I would expect that 3.0//4 should fail. It only takes integer values. 3.0//4.0, even though they're compatible. Okay. So something's not quite right. Like when this function says it's an int, oh, we probably never create values with ints. I think that's on our divide. Yeah, look at this. Integer value. You're supposed to find that. Jump to definition. What? I bumped something. Okay, let's try again. Jump to definition. Okay. Yeah, so his constructor defaults to number. But in this case, we really know it really is an int. Okay, so I guess we're trying to prove that convert to integer value. Let's see if there's a test for this. Callers. I hate this. It's like we're calling it at the top of this file. We know we are. Did I bump something up here? Maybe I better build again. Convert function integer. All right, what have I done? Curry, convert equality operator. That looks the same. Curry, convert equality operator. That looks the same. Failure. Oh, how weird. Okay, we're going to clean and do a build. Yeah, once in a while I find these Xcode bugs and I just don't know how to interpret. Now, what the heck is going on? Expected. Oh, did I bump? I must have dropped an extra brace in there somewhere. Well, I was looking at convert int value. Convert function integer. That seems okay. That's okay. What's going on? Where'd this trouble start? convert function to double. There's that, and there's that. I don't think I even changed it yet, did I? Oh, they went away. Okay, let's run tests just to make sure. Yeah, clean twice seems to help. Like what? Of course, now it can start failing again, and I'll be all right. We're looking for this one. Jump to definition. Now we want to see the callers. Primitive functions. Nobody's testing it directly. Okay, well, we'll add one. Primitive function tests. Some primitives divide integers, turns to double first. Okay. Prefix operators. Curry. All right, let's test. Test int divide returns int. That's a good one. Primitive functions dot. Okay, they're a little weird to test, so let's take primitive functions dot convert function integer of slash. Okay, that gives us a closure that takes two arguments. So let's take result equals that called with 4 divided by 2. Oh no, we got to do Elm expressions. Well, let's get the function. Okay, so let the function equal that. Okay, and then if we call function with integer value 4, integer value, let's make it 6, integer value 3. Okay, now the result should be 6 divided by 3 is 2, but its type is known to be integer at this point. Okay. So I guess I'm interpreting number as it's an int that you can convert to float for free. Yeah, okay, we get an error. That's a good thing. 2 is not equal to 2. Well, that's because the types aren't equal. And maybe we don't even care the values so much. Well, let's assert. Let's catch the type first. Result.type should be ElmType.integer. Okay. And then the value should be add this forward to okay. Result.type should be integer, and the result should be 2 with ElmType.integer. It's already included in there, but the error messages are better, so that's why I'm doing this. At least I predict the error message is better. We'll find out. I think it'll say something about number and int. Number is not equal to int. Perfect. And the value is then not the same. Okay. So let's go to primitive functions. This thing, returning integer value, it should be returning an integer value with ElmType.integer. Okay, so before it just said, oh, I'm returning a number. Basically, it returned a number. And we are trying to say, no, we're forcing it down to an int type. Feeling good. I think this will work. Oh, okay. Something's not working. Where is it? Prefix operators numeric. Okay, we'll let's take a break and come back and fix this other test. I think I see what's wrong already. But 2-minute break. Welcome back. All right, you probably saw the error. 3 is not equal to 3. It's the same error we had before. Integer values, whether currently known as number or int, are fine to divide, but the result has to be an int. And that's just the nature of the // operator. All right. Yay. Okay, so what we did is we made int divide return int, not just number. Nice. All right. I guess that is that. Integer / knows the int type. All right. Okay. Make operators tell their actual type, not just unknown. We've done that. But who's using unknown? Let's go find them. Unknown. Can I just do callers? Yeah. No. Let's look for .unknown. That'll give us something. I don't know if they're all going to be, yeah, the error messages have some unknowns. ElmType, function call. Okay, so function calls return ElmType.unknown. All right, well, let's add that to the to-do list. Function calls should not return unknown. Okay, who else? Primitive functions. We're defaulting to unknown. Well, let's see who calls curry. All right, I'm going to say another task. Make all callers to curry be explicit about types. So if they want to do unknown, they got to explicitly say it. All right, RHS, yep. Variable. Error message is unknown variable. Okay, that's an error message. Error message. ElmType unknown. Well, that's one for function call. So right now we're saying we don't know the type of a function. Seems lame. ElmType unknown. Again, function call unknown. Function call unknown. Error message. Tuple tests. Tuple of an int is unknown. That's not correct. It really should be the type. A tuple's a compound type. Well, we haven't dealt with them yet. Okay, I can see why it's unknown. But it shouldn't be. Tuple types. Let's add that to the list. Tuple types should not return unknown. Now, what's interesting is we know that at least some don't, right? Because we did. Well, let's run it. I think the rest of these unknowns here. Okay, one more error message. Okay. So right now, tuples function calls are the two things that return unknown. But I thought our tuples kind of worked. Maybe I wasn't paying enough attention. 3, 4 should be number. Yes. Okay. What was that test then? EQ. Integer value. No, his tuples don't do this. Maybe they did at one point. Let's see what tuple does for types. Well, he mostly takes what you tell him. Okay, and where's our tuple? Tuple is an array of types. Okay, that's as good as I could hope for. Yeah, that I don't like that test. I mean, basically, this should be ElmType.tuple with integer value number. Value 2. Now, if you want to make this one unknown, well, no, that's different. I'm going to say this may have happened maybe early on. We didn't support the tuple type properly, but we have tuple. And it takes an array of types, ElmType.number in this case, ElmType.number. Okay, so in our example, 3, 4 came back to number. And that should be fine for that. This should be the same type. That one can be different because it's the same value as different type. All right, let's see if this passes. It should. I mean, if you ever did create one with unknown, then yes, you should handle it. The type should be regarded as matching if unknown matches something. But all right, that's good. And that was the 3 cases. All right, so we did tuple. It's kind of a different story. Tuple. It really was a case of fixing the test. To use real tuple type not unknown. I think that's accurate. See who uses unknown. The only one left is function calls. Make all callers to curry be explicit. Okay, so let's let me run them again. That was one test to make sure everything else is okay. Okay. Good. So I guess we made tuple tests use the ElmType.tuple type. How about just use ElmType.tuple not unknown. Okay. Callers curry explicit about types. So let's go find curry. I'm just going to close all these. Curry was in primitive functions. Okay, so well, I'm going to take off these 3 lines and see who breaks. It's got to be some. Oh yeah. Is this going to be too hard? Well, worst case. What's the problem? Oh, no, I don't want to take them away. Let's undo. I want to take away the predefinedness of them. I don't think we can escape them because this is the thing that tells us like what Elm type corresponds to our Swift types that we're using. So I think that's probably more accurate. There are going to be some that don't use it probably. Did it say it's okay? Wow. No. Missing parameters. Okay. Really, that's the only one. Okay, then it should be the same as our one up there because we're really kind of testing how it gets used. Yeah, just number. Convert with number as a primitive, then a function. Apply. All right, let's see how this does. Oh, so only one place. Now that all our primitives do it. Nice. Okay. So let's get our 2.2. Make all curlers to curry, be explicit about types. I think that is still around the infix operators. All right, and that passed tests, so we'll commit. Make all callers to curry. All right. We're knocking some things off the list. That's good. Okay. Should we allow operators on the right side to we should allow them to define if and whatever else. Yeah. That strikes me as painful. Functions should evaluate functions on the right hand side. That's a problem. Okay. I'm going to push this one off a little. Because I think there's just other stuff on our function calls. Let's see. This was a note to ourselves. Lambda x 3.0 goes to 3.0 a float, but 42 lambda x goes to 42 unknown. Let's see if that's true. I don't know if I'm not sure. All our function evaluation still seems a little... Can I do that? Did I copy it correctly? Kind of moving between the Xcode and the interpreter is not always... Yeah. Okay, so it was 42. Lambda x goes to x applied to 3.0. Unknown. Okay. Well, it's coming up unknown in parentheses now, which is a little odd. But that's a future issue. Okay, function calls should not return unknown. Yes. All right, so let's go back to unknown. Sorry, this is primitive functions.swift. I guess I didn't get the... Okay. Function call should not return unknown. So we really want ElmType. And I think we're back to searching for .unknown. ElmType return unknown. Oh, maybe we added the parentheses now. Function call. This is suspicious to me. Now, let's see. This should be like if you say function of xy equals some function, and then you say function of 3, 4. Right? Let's try it. Function of xy equals tuple xy. Okay. Function of 3, 4 should be a tuple 3, 4. Okay, type generic, we talked about that, but nobody's unknown in this scenario. Maybe unknown's not really happening. Function call, that's... What is that thing? I think it's... Well, I think it's applying its functions and it's getting the right type as a result. So this is... I think it's showing up because there's this intermediate stage where we build up this function call object, but it's not really... I don't know, it doesn't survive. We end up calling the closures on it. Maybe that's just to evaluate. But, I mean, the argument, the first function, I don't know. Well, this is probably why I punted. So the first expression is the function call, right? So that's result is the evaluate the first expression 0. That thing has a type. Has a closure. I almost think like evaluating the type is going to be like doing this, but we can't. Right? Is there an issue? Because the function itself could be a variable, like returning another function, and do we know the type of that all the way down? I don't know. I mean, if it was just one level deep, you'd have function xy. We know the type is tuple of number, or generic at least. Okay. And so we had x, well, let's go to it. we had function of xy equals, it's a function of a goes to tuple AA. Okay, so 3, 4, it's the right-hand side. It's the farthest right-hand side of the whole thing, but that's only because we evaluate both. If we do a function of 3, we should get a function returning a goes to tuple. Yeah. Okay. And we know there's an issue with evaluating functions on the right-hand side, so there's more going on than this. So if we said function g of x equals function of xx, I don't know what we'll get. Yeah, this is wrong, right? Because this should be function of a goes to a goes to tuple. When you evaluate g of x, let's try it. G of 3. I think this is what doesn't work. He returns a function from a to AA. That's just not really right. The first one, g of x, should be a function from a to AA as well, because you're passing in a complete set of arguments. So function of x should be a goes to a goes to tuple, and then a goes to tuple applied to a should be tuple. So the result of the whole right-hand side should be tuple. And so the function g of x should be a goes to tuple. Whew, boy. But if I had, suppose I had some variable that was a function, h equals g. Maybe pushing it here. I want h to be a function from a to tuple. It's not tuple because it's confused about g. Let's try j equals function. He's got the whole deal. Oh, okay. This is why I get headaches. Result as closure. I keep bumping that. That's not good either. Right. So I think the fact is the function call, I don't think he can know that much about what he's producing yet. That seems weird. And it sounds wrong to me, but I guess it probably is wrong, because you probably, in this case, you're probably going to be restricted where h equals g. If I try and pass h along to something else, it's going to want to enforce this type. And if I had j, they have two different types, correct or not. I can't use them interchangeably. Well, I'll try. I don't know if I can. Whoops. I guess I'm not getting my focus where I expect. If true, then h else j. I would expect that to not work. Yeah, there you go. Function a goes to a. So it got h. Let's try if false, then h else j. Okay, so it doesn't seem worried that the if statement has two completely different types on the right-hand side. That sounds wrong to me. Okay, let's replicate this over. Can I scroll that? Yes, so function xy equals xy. function xy equals tuple xy. AA goes to AB. AB goes to AB. Okay. Function of 3, 4 should be fine. 3, 4 number 1. Function of 3 should just be the tuple. A goes to tuple. Yep. All right, now we're going to say g of x equals function of xx equals function of xx. All right. Yeah, this thing knows function of xx is a goes to b goes to ab. So you give me an a, I will produce the same thing twice. Yeah. Okay, g of x equals that. H equals g, and j equals function. If true, then h else j. I think it's going to fail. Yeah. J value goes a to b to tuple, and the right-hand side, the left-hand side goes to a goes to tuple. Okay. All branches must produce the same values. Hint, it looks like it takes too many arguments. I think that's just misleading and wrong. Okay. Does not match all the previous branches. So if true, then H, else if false, then J, else H. Yeah. Second branch does not branch. Okay. If true, then H, else if false, then H, else J. The third branch. Okay, it's counting. All right. So where's this leave us? Wow. Well, I think, well, one thing I think is because I can see 3 debugging breakpoints that we had at some point, that this is tricky. But I think what's going to have to happen is I think this has got to be a calculation, and a pretty complex one. Creating a function call from a bunch of expressions. Let's see who builds one. Callers. How about here? Post order tree. Okay, this is our operators getting turned into function calls. Now, I mean, for operators, variable expression is string. Oh, that's the operator itself, so it turns it into the function call. Well, we'd have to look them up to know them at this point. Oh boy. Right, so we're providing the string form of the function name. I mean, really, we need to look up. Well, maybe that's what has to happen before. We got a variable for a function call. We look it up. Maybe this is why things are sort of working. All right, let's look at variable. Okay, so variable, basically, it says it's generic. Then when you evaluate it, you get something. You get whatever the symbol table says. Expression.evaluate context. Expression is the context subname. So look up the function and evaluate it with context. And context subname should have the type. So I think that's fine. I think this is redundant. Token prefix operator goes to variable plus, goes to lookup, goes to the primitive. Yeah, that's kind of an outline of what we did. All right, so the variables type depends on what's stored in it. And that's sort of true. Like we know we can say function xy equals something and then function xy equals something else with different types. And it's okay with it. It just keeps the last thing and uses it. But this expression evaluate, eventually somebody's got to get the types in there. Oh. Okay. And where are we? So function xy, this one looks right. Well, we know there's an issue on the right hand side, and maybe that's the real issue. G of 3. Let's try G of 3, 4. Should be a tuple 3, 4. Interesting. Something's weird. I don't think it's just my head. G is a function, calls function with x twice, and x should be happy. Sorry, function should be happy to evaluate with 2 values. But we somehow got an extra layer of indirection in here, an extra argument. Okay, so I think we're back to, well, I got a couple of just edity kind of things. Let's make sure things run and we'll push those. Yeah, this may be a case where pushing off some decisions just wasn't wise enough. Function call should not return. No, we haven't fixed that. Okay, so let's commit this. This is just minor edits. I don't bother with more. All right, so we want to know function should evaluate functions on the right hand side. Oh, so maybe our function xx on the right hand side wasn't evaluated, and it was just producing the function itself without the arguments. All right, so we'll take a break, 2 minutes. We'll come back, figure out some sort of test for this evaluating functions on the right hand side. And hopefully that unlocks some of this. All right, see you in a couple. Welcome back. All right, so evaluate functions on the right-hand side. Let's go back to the parsing and just kind of trace it forward. We haven't looked at it for a little while. The parser. Okay. Let's see, where are we? Okay, there's our initialize. Okay, parse. So if token can start expression, you're a function call or a definition. And that goes to expressions equals expressions, which is optional. If you're a function call, well, the right-hand side, you've already done var plus whatever equals. Now we got the expression. Function definition. Okay. You're either a function call. Well, that doesn't seem right. Partial result. Okay. That's the expressions. And if there's any errors, you return error, and then you look for the equals. And if you get the equals, the function definition works on the well, partial result is not helpful, is it? It's sort of like the left-hand side is a better name, maybe. And I allow myself that abbreviation. Left-hand side equals operator expression. If it's an error, return it. And if there's an equals, then we take a function definition out of the left-hand side. Okay, and if it's not, then we just return the left-hand side. That seems correct to me. Better naming. All right, now here, partial result is really not a partial result at all, is it? It's really the left-hand side. But how would it be a function call? Yeah, it would be a function call if it parsed out as 1. Okay, because it could be 3. It could be function equals constant. It could be a constant definition. Function equals 3. Okay. Sort of a function of no arguments. We would say, oh, that's just an expression. Let's return that. So again, I'm going to say left-hand side again. Okay. And yeah, that should be well. Okay, we're doing a bunch of validation on it. Okay, so we capture the location, we skip the token because we're at the equal sign. All right, so we got the left-hand side is a function call, then it's a bunch of expressions. If it's a function call, we take the expressions in it. Otherwise, we just return it. So I think what we're saying here is, I don't know, expers is not, it's like, they're like definition terms or something like that. Let's try Elm definition. Not the right way to go. Okay. Elm definition language. There's too many Elms out there. Elm programming language. Declaration. Maybe that's a better word. Elmlang.org. Syntax. Well, it's not a let. Let's take function. Okay. Function. Yeah, they just don't. They don't give you the words to use here. I think, what can we call this? Is the declaration, function declaration? Excuse me. Definition. I mean, it's really the name plus the arguments. Maybe that's even a better name. Left-hand side, expressions, filter. Okay, this is really only to make sure everything is a variable. Okay, but what is expressions? It's the, I'm going to call it the function declaration or definition. What is the word for that? It's not prototype. Function prototype? Yeah, maybe it is. Maybe that's a better word. Okay, function prototype. If the left-hand side is a function call, like a function of x, y, then we dig out its expressions and return those as the prototype. Otherwise, it's just a single variable, and we use that. All right, then we go through the function prototype, catch all the variables, yeah, and we make sure they count, make sure they're all there. There's probably a better way to do this. We're filtering out the ones that are variables and mapping them and then counting them. Then I got LHS again. Ugh. LHS. Wait a minute. LHS is here, and then I'm reusing that name. That seems like bad luck. LHS. I'm going to call this LHS variables. I didn't even know you could redefine a variable you used as a definition up here. Okay, variables is the function prototype count. Huh. That would be nice if I could just say if function prototype well, we know function prototype is an array of expression. Let's do a little Swift research. So Swift collection, I don't know. I'll just say filters. I don't really care about filter. I probably want to get it up to the collection type or the sequence type, maybe. I want to do like a find any or find all. All satisfy. That's what I want. Map to bool returns bool. So is variable. Okay. Function prototype dot all satisfy $0 is variable. Okay. I want it to be all variables. If not all variables, then I do a message. Okay. And then who's looking at this thing? that's kind of confusing. Somebody should complain. Yeah. Okay. Let's make sure this is still coherent. I still think we can get rid of something. Okay, I think the first part's better anyway. Function prototype, we take the left-hand side. If it's a function call, then we dig out the expressions. Otherwise, we dig out the one item on the LHS, the one item in the left-hand side. Then we make sure they're all variables. If not, then we do an error message. Okay, so if they don't all satisfy being a variable, then we complain. I think I can, yeah. Function prototype all satisfy being a variable, we can complain. All right, now here, that's fine. Now LHS variables, I don't need the filter anymore because I know they're all variables. So I can just say map, force them to variables. And the type of this thing should be array variable. Yes, okay. Now, but I don't even know if I need that. I've got expressions. Function prototype still. If I dropped the first one of that, variable lambda expression variable.name. Okay, so I think I would have to cast something, but I have to cast it anyway. It's hard to get this clear enough. Okay, so what I'm saying, the right-hand side, I'm going to format this a little bit too. The new right-hand side is take the variables, drop the first one, the function, reverse them, so xy goes to yx, reduce the right-hand side value variable. What's value? I guess this is the previous value. We're going to map lambda expression containing the previous value. Yeah, okay. So we're sort of saying function of xy is y goes to the right-hand side, and then x goes to the lambda expression of y going to the right-hand side. So we're turning function of xy into a double nested lambda expression, which is what it should be. That makes sense to me. LHS variables dot name definition. He knows he's a variable. Maybe this is okay. Function prototype. Okay, so we're mapping. This is like enforcing. And this error stuff really gets in the way. But anyway, this is enforcing that everything in the function prototype is a variable. That's a true thing. All right. Then we're gonna get a list of them. Now, if I just used function prototypes instead of LHS variables, let's try that. I mean, they're supposed to be the same, except one's array of expression and one's array of variable. All right, expression has no member name. So there's some benefit to forcing it to the variables. we'd have to cast it here and here, and this saves us from these casts. The other way, well, what if I mean, I could do the cast in a try. Would that be an improvement? I mean, what I want to do is get down here with LHS variables being all variables. Okay, so let's try it. Let LHS variables of array of list of variable. Array of variable. Okay, yeah, I know. I'm gonna say what is it? Do catch. You gonna volunteer? Yeah. Okay, so we're gonna try this. Function prototype, yes. I'm gonna comment this one. Okay, so we're gonna match them, and I'm gonna catch anything. And if I get an error, I'm gonna do this. Okay, so no calls to throwing functions occur. Now how's that? They're going to complain? No calls to throwing functions, but this can throw. Expression is not convertible to. Can I do this? But that's going to give me a null. Well, I don't think this is coming out right. I had hoped that doing this would say, yeah, that can fail. It might not be that type. And then catch, but apparently that's not the deal. All right. Now we can't. What can we do? Well, another thing I would not mind doing, I mean, I guess all of this 104 to here is trying to enforce. It either gives me an error, or it gives me the LHS variables all mapped to variables. Excuse me. Now on the if statements, we were able to separate out semantics method that did this. We had enforce if semantics, and I would like to do the same kind of thing. Let's see what we can do. Okay, so if you gave me the left-hand side, I could give you back the LHS variables, and that would be good. We don't need the prototype anymore down here. Okay. or I would give you an error expression. Now the array of variables, I want an array of variables. The way I'm looking at this is like, is there a tuple I can write that will do it? All right, so if I'm going to say enforce enforce function prototype is all variables. It's got some arguments, it returns something, and then it does all this. All right. Well, it's certainly going to return, I guess what I'm going to return is a tuple, and one possibility is an array of variables, and the other possibility is an error expression. Okay. Now you're going to have to give me the left-hand side, whose type is expression. Okay. That should make that all happy. And then here equals location. Well, I guess you're going to have to give that to me too. Type is location. Location of type location. I won't call it equals location. I'll just call it location. Okay. Now the return types are wrong. All right, he needs to return a tuple. So he can return nil with this. Maybe that would be clearer. Probably clearest if I put them on the same level. Okay. Otherwise, we were going to return LHS variables and nil. Okay. Now there may be a better way. As always, I'd welcome your comments, suggestions. So enforce function prototype is all variables. And if it is, you give it to me. And if not, it's an error expression. Okay, so let's suppose you did all that. And we're going to try and do something here instead. So we're going to say enforce function prototype is all variables. LHS and equals location. That's the stuff coming in. And then what we get back, I think I can do it this way, is variables and error equals that, and then whoops, that red, I needed a let in there. Let. So variables and error comes back with the function types defined. Error was never used. Okay. So if error not nil, we're going to return error. Error. All right. And then if it is, then LHS variables down here, LHS variables equals variables. Okay, and then I think this stuff can go away. And this. Let LHS variables equals variables, bang. And I could almost just use them directly. Let's see if it works. So we're trying to pull out a method that will make it more clear that we're getting to the bottom of this thing with a bunch of variables, or else we bail out with an error. I think it's better. All right, let's dump this. And maybe this is prototype. Let's try that. Rename this to the prototype. And then I'm going to just use prototype down here. LHS variables is prototype or prototype. Now I think I'm not using this anymore. Now we could even move this up. Let's do that. So the reason I'm moving it up is I want, well, it's nice if I can get the parsing part in the front, and then everything else is enforce semantics and figure out what you're supposed to do and do it. Let's see if that's good. All right, I'm glad about that. So what do we do? We improved function call or definition, and that's in parser. And I know it's not a static method. That's okay. All right. I think it's easier to understand that you got var plus equals. You got here. You consumed the equal sign, and you process the expression on the right hand side, which is not really the right thing just yet, but it's okay. And then you enforce the function prototype. All variables gets you back a prototype. And maybe I could, well, let's see if we can pass back a value, even if it's an error or something like that. Okay. Array of variable. Okay, we'll pick up there tomorrow. Let's see. Tomorrow's Wednesday, 9 to 11:30 a.m. Eastern time, Eastern Daylight Time, and I think we'll do a little bit more work improving this function, and then just kind of keep on it and get to the bottom of the function stuff. I think starting back at the parser and just trying to do everything right from here. I think what we'll end up doing is treating the type stuff as more of like an abstract interpretation, so we don't have the values, but we can apply the types kind of recursively, and I think that'll let us get to the right type. We'll have to see how that goes. Anyway, thanks for joining me today. I will catch you in the future. Have a good week. Bye-bye.